probability, Venn diagrams and set notation. We have two events, A and B, with their probabilities. A dash is the complement of event A, so that's event A not happening. So 1 minus this, 0.6. Likewise for B dash. We're given that A and B are independent. This is set notation. It means the probability of A and B. So that symbol means AND. Because A and B are independent, we can multiply their probabilities together. So the probability of A and B is 0.08. On a Venn diagram, A and B means where A and B both overlap, or where they intersect. This is the region where they intersect, and the probability here is 0.08. This circle represents the probability of A, which is 0.4. So if this is 0.08, then this side will be 0.4 minus 0.08. And likewise, this circle represents B, and the probability of B is 0.2, so 0.2 minus 0.08 will give us the probability on this side. And inside the rectangle is our sample space. All of the probabilities inside the rectangle add up to 1. So the missing probability here is 0.48. Part B, the probability of A dash and B. So that's the probability of A dash times the probability of B. So 0.6 times 0.2, so 0.12. The order here will not make any difference, so the probability of B and A dash is exactly the same as this. On a Venn diagram, we're looking for the region that's A dash, so everything that's not in this circle, where that overlaps with everything that's in this circle. So everything not in A is shaded in yellow, everything in B is shaded, and we're looking for the region where the two overlap, so where this region overlaps with this region, and that's here, so 0.12. Part C, the probability of A dash and B dash. So we just multiply their probabilities together, these two, so 0.48. Again, what does this look like on a Venn diagram? So where does A dash overlap or intersect with B dash? So A dash, so everything that's not in A has been shaded. B dash, so everything not in B has been shaded. So just going backwards and forwards between the two, identify the region that's common to both, where they both overlap, and that's this region around the outside. So everything in green now is not in A and it's not in B. Example 2, we can see there's no overlap or intersection between A and B, so the probability of A and B is 0. They are mutually exclusive. This is the formula book for Edexcel, and this formula here is known as the Addition Law of Probabilities. Again, in set notation, this symbol here, A union B, or A or B or both, that's what this stands for, A or B or both. And this one we've come across already, just means AND, A and B. Example 4, so Venn diagrams can represent probabilities or frequencies. So we've got frequencies in this one. If we add them all together, we get 30. So if we wanted to, we could divide these all by 30, their total, and that would give us a Venn diagram in terms of probability. But I'm not going to do this, I'm going to stick with frequencies in this example. So we want to work out these probabilities. So A is just 10 plus 3, 13 out of 30. Probability of B, that's the 5 plus the 3, that's 8 out of 30. A and B, this region, so 3 out of 30. A or B or both, so that's everything in A, everything in B, so that's the 10, the 3 and the 5 added together, so 18 out of 30. So we get these probabilities. Now let's have a look at the addition law for probabilities. So A or B or both, we've got 18 over 30. Probability of A, 13 over 30, probability of B 8 over 30, and then minus A and B, which is 3 over 30, and the equation balances. And all this is showing is that if one of these probabilities was missing, you can use this formula to work it out. You don't really need to use a Venn diagram each time. Example 5. So we have two events, A and B. Their probabilities are given. We know the probability of A or B or both, which is 0.9. We have to work out the probability of A and B. So you might think, well, why not just multiply the 0.4 with a 0.55? Now you can only do that if you know events A and B are independent, and we haven't been given that information, so we're not going to do that. We're going to use a Venn diagram approach. So the region we're looking for is this section in the middle where A and B overlap, and let's call the probability of that region X. That means the probability of this shaded region will be the probability of A, which is 0.4, that's all of this circle, minus the X there. Then likewise on the other side it will be the probability of B, so all of this circle again is 0.55 minus the X for this shaded part here. Now these three probabilities represent the probability of A or B or both, and that's 0.9, which means this has to be 0.1. So we set up a simple equation. We've got three probabilities, these three, and we're given that they add up to 0.9 already, so we solve to get X. So the probability of A and B here in the center is 0.05. Now are A and B independent? If they're independent, then we can multiply their probabilities together, which is what I've done here, and we get a different value to what we've got in the Venn diagram here for A and B. So A and B are not independent, because this value and this value differs. Now part B, we're answering the same question, but we're going to use the Addition Law of Probabilities formula this time, so straight from the formula book, and 0.9 A or B goes here. A, B, we've got those probabilities, this is what we're after. So substitute in the probabilities that you have and then rearrange, and this again, it's a lot easier than doing the Venn diagram approach. For practice, try these questions.